it is part 2 of section 1.1, functions, generalization, and reusability. A good programmer would implement codes such that they are effective, easy to modify, and reusable. To understand reusability, let's consider the following simple example. Find the sum of the square of consecutive integers from 1 to 10. The problem asks to evaluate the quantity 1 squared plus 2 squared and up to 10 squared. In sigma notation, we can write in this way. For this problem, we can write a MathTalent code as in this box. First, we initialize the square sum is 0 and through this repetition for loop, we try to add and 1 squared, 2 squared, 3 squared, and so on up to 10 squared, so that after passing these lines, the square sum will have value 385. This code is a simple form of repetition, one of the most common building blocks in programming. Here, this MathTalent program produces the right answer. However, it is not really reusable. If you try to get square sum from some other number, for example, 10 to 20 or 10 to 100, then you have to rewrite and you have to adjust this one for the new task. So that here we have to write a function and reusable for various situations. In order to do that, we have to implement code with a variable input. And now the program portion must be saved as a form of function. So let's try to generalize this program. Now the same problem, find the sum of the square of consecutive integers from rather than 1 to 10, now we try to use variable m to n. Now that is the program. Here, square sum.m, and the file name is square sum.m, and now the function is organized in this way. And function, so it's declared now in below it is a function to be defined. And square sum, there's output, and that is the function name. This is input. So by using this input, this command will produce square sum. Now this portion is exactly the same as earlier that one. So that in a sense, if you implement the code, then just wrap up with this head portion and save into as a function in a separate file, then that is a function. Okay, such file in MathTalent is called M file. And here, let's try to run this code by using MathTalent. And an alternative, free alternative is Octave. Here we have in the directory, you can see here now square sum. And okay, that is implemented here. In this directory, now we'll go to command window, and here earlier I tested this one, square sum 1 to 10. It is already I did so that it is keeping the memory. So square sum 1 to 10, the answer is 385. Also for that one, help square sum. Then Now, these are some extra lines, but that portion is coming from the program. Okay, let's go over there. This portion is a sort of a documentation for the program, explaining about the program. So you included this portion, then by using help command, you can see what it is. So here you have to explain what it is. Okay. Okay, that's the Octave running MATLAB code. Okay. Now here the first line is specifying the function name, which is a square sum, and input variables mn, and output is now sq sum. Lines 2 to 5, okay, here from here to there, that is a kind of the help. Along with the help, you can get it. Already I explained that. If we put help, then you can see this output. But in Octave, some extra lines are coming out. But if you are using MATLAB, just simply you'll see only this result. And last 4 lines of the algorithm include the required operations for the given task. So that portion is the main part of the program. And on the command window, and if you write down square sum 1 to 10, then answer is 385. We already experienced this along with Octave. Okay, that's the second part. Thank you.